When dragons on planet Pern lay eggs, the eggs are either yellow or green. The biologists have observed over the years that 19% of the eggs are yellow, and the rest are green. Next spring, the lead scientist has permission to randomly select 48 of the dragon eggs to incubate. Consider all the possible samples of 48 dragon eggs. What is the mean number of yellow eggs in samples of 48 eggs? That's the same thing as asking for the expected value of the number of yellow eggs. Give your answer correct to at least one decimal place. So to calculate this, normally to find an expected value, we need to put all the values of our random variable into L1, all the probabilities associated into L2, and then use one var stats L1, L2. But if we knew the type of distribution this was, that might be simpler. So for instance, this distribution should be binomial because there's two outcomes, green or yellow egg. The probability is the same for each trial, so every time an egg is laid, there's a 19% chance that it would be yellow. And we have a fixed number of trials, so there's 48 trials in the experiment. So this is a binomial distribution. Now, since it's a binomial distribution, we can use the formula mu equals n times p to find the mean of this distribution, and the mean of a distribution is the same thing as the expected value. So n is 48 in this case, p is 0.19. So if I take 48 times 0.19, and that gives me an expected value of 9.1. What is the standard deviation in the number of yellow eggs in samples of size 48? Give your answer correct to at least one decimal place. Well, the standard deviation of a binomial distribution is the square root of n times p times q, where q is the complement of p, so just 1 minus p. So if I take the square root of n, which is 48, times p, which is 0.19, times q, which would be 1 minus 0.19, then that would give me the standard deviation. So let's try it out. So first off, 1 minus 0.19, that is 0.81. So if I take 48 times 0.19 times 0.81, then that gives me 7.3872, and I need to take the square root of that answer, which is 2.7, because it said to do one decimal, so 2.7. What is the variance in the number of yellow eggs in samples of size 48? Well, the variance is the square of your standard deviation. So the formula here would just be n times p times q. But I've actually already done that in the calculator because I did that first and then I took the square root. So 2.7179 squared would be 7.4 when I round to one decimal. So 7.4, because all I've done here is done 48 times 0.19 times 0.81. Now, if you take your answer from the previous box, so 2.7, and you square it, do be careful to make sure you use enough decimal places. Because if you'll notice here, I've got 7.3 when I round to one decimal, which is slightly off. It's the correct process, but I've got rounding error here. So if you do something like that, try not to round your value off. And that's what it's saying here. Calculate the answer using at least 5 decimals. So if you did 2.71794, so there's 5 decimals, and you square that, then you'll end up rounding to the correct number of decimals. So the same answer, 7.4.